Hi everyone, I'm Sertan and I will do, I don't know what is the number in the presentation. I'm in the order and I will just explain you my research, which is about linking scores and audio, and I will specifically talk about Makam music of Turkey in this presentation. So I think we all know music can be represented by various data sources. So we can use audio recordings, scores, videos, lyrics, or even metadata like editorial metadata, musicological things, or genre tags and things like this. So the first two ones that I mentioned, the audio recordings and the scores, are probably the ones that we use the most in our computation research. So if we look at the audio recordings, we can actually extract a vast amount of information, like let it be timbre or melody, rhythm, or anything. Like we kind of have some algorithms that we can fetch them, let's say, magically. And if we look at the scores, and by scores I mean the machine readable ones, we have a very easy to access source. So because they are symbolic, it's kind of easy to extract them and kind of find the melodies, or if we are working on Western music, maybe we can check the functional harmonies and things. And the music scores usually come with complementary information like the tempo, the rhythm, or the key, and things like this. So if we can actually link these sources, and by linking, what I mean is marking the locations within an audio fragment where a score fragment is kind of performed. Like let's say I have a score, a chunk of score, and I have an audio. I'm basically searching where this small chunk is played in an audio recording. If we can actually do this, we can really benefit from both of these aspects, like the complementary information. So let's say we actually link a score and an audio in a document level. We can say like this audio, like this piece has been played in this audio. Or we can do audio score alignment in the note level, and we can understand how every pitch is played, like what is the tuning aspects, or how people kind of use their musicality to express, like play a composition, and what are their differences that make them musical, and like lots of applications like this. So our advantage with Makam music of Turkey is we actually have a lot of scores and a fair number of audio recordings within our data sets. And currently I'm using a small set, but by the end of the PhD I plan to incorporate them in as much as possible, and it will probably reach to the total numbers. So as I have been explaining, there are like different depths of linking that you can do with scores and audio. Maybe the highest level I can talk about is the linking the whole score and the audio recording in the document level. It's basically finding when a piece of music, a sheet music, is played in a audio recording. But the thing is, it doesn't, like we can go a little bit more specific and say within this audio where the score is actually being played. So let's think of the third example, and let's assume like this is a concert. So there will be like some consequent performances of different pieces. So we can actually say the score 1, the composition of that was played in here, then the score 2 came into the area, and things like this. And maybe there were like some interludes in the middle which are not really related to any of these scores. And let's say we actually did this process and we find the chunk of audio recording and the score that are actually like they are linked in the document level. So what we can do is we can go one level deeper, and we can actually start linking the musically relevant sections, the structural elements, and we can actually try to find where within this like duration each of these sections are getting played. And we can go deeper, and we can link the measures, and we can even go into much deeper into the beat level or the rhythmic cycles level, or even in the note level. And when we are actually going into these higher positions, we will have a lot of challenges and lots of conceptual questions that we have to ask to ourselves too, like how we actually would like to do this. So you might be actually asking me, if you were kind of looking at the scores, like they're all monophonic, like there's just a single line of melody. So how can it possibly be, hard if we are kind of like, this is not like Fürelise, which has these all functional harmonies and chords and things. But the thing is, we are not actually dealing with, let's say, the nursery rhymes in here. And like to kind of show this, I will play this chunk of audio, and I would like you to sight read if you know scores, and if you even want to make a solfege, feel free, and you will kind of notice like there will be actually a significant difference from what the scores are explaining within our, let's say, Eurogenetic understanding and how the scores of Makam music are seen. So you can even see, like, I tried to track it with the mouse and I'm missing it for a long time. And the thing is, like, one of the things is, it's not maybe missing, but we should actually see it as a guideline. So maybe some of the things you might have noticed, and I will continue talk about them. Maybe the most sound one of these challenges are is the fact that there are more than 12 notes in an octave in Makam music. Like the musicological studies say it is at least 17 to 79 or some other numbers. But the challenge that it brings is it's not like the pitches are not definite. So the tuning changes from makam to makam, from performer to performer, or even the same performer might play a note differently in a performance of his than in a concert or things like this. So we don't know where these pitches actually reside in. So, and on top of it, we also like the performances, the interpretations of these notes, they are connected within the phrases that are being done. So if the musician is playing an ascending scale or a descending scale, or if he wants to emphasize a note, if he wants to show a note is unstable, there will be a very different intonation of this, which can differ as much as a quarter tone within its like the note's temporal length. So we cannot really say, hey, we found something close to 440 Hz and it should be A. So this kind of requires these knowledge-driven methodologies. And as I said, these are simply guidelines. And you have heard like the musicians actually deviate from it considerably. Like they use a lot of embellishments which are not indicated in the score, like they are not supposed to indicate, and musicians actually play with them all the time. This is how they show their virtuosity. And they can just repeat like sections, they can repeat phrases within any section, and they can just start improvising in the middle and go to the piece again and so forth. And maybe the most interesting one and the challenging one is the so-called heterophony. What people do is they, like one of the musicians, let's say, he will hold a note, the other will start doing the melodic line, then the other will do note repetitions, he will even add like some small phrases to connect these melodic phrases. And these things actually bring this challenge, especially when we go to the deeper levels, into the note level, like how can we actually link a score and a audio if the notes are not actually played or more notes are played. So the core of my methodology is basically I have these two chunks, a score fragment and an audio fragment, and I basically want to find where this score fragment is within the audio. So the first thing I do is I compute this synthetic pitch track from the score according to the theory, and I normalize it with respect to the tonic symbol of the makam. So it kind of gets normalized. And then I compute a prominent pitch from the audio recording, and I do tonic identification, so it also gets normalized, so I don't have to deal with the pitch heights. For the prominent melody, I'm using the Essentia implementation of Melodia. And then at the next step, I basically compare them, and I compute a distance matrix from between the score and the audio. And to emphasize the regularities, which is a little bit hard to see, I guess, in here, I do this binary thresholding, and I allow a, let's say, microtonal deviance, which is kind of known by like the musicologists. So it's around quarter tone, let's say. Then what I do is I apply this very common image processing technique called half transform, and I detect the lines which kind of indicate where the sections might have been played. And I do a simple cleanup, so the duplicate candidates are removed, and I basically find these locations in the audio. So far, we applied this technique to two problems. The first one is the tonic identification problem. So I should maybe go a little bit specific about this. Basically, Makam music, the tonic is not a definite frequency, like, as I said, A equal to 440 hertz. And there are like the transposing a music is very common. Like it can be transposed according to the instrument, the vocal range, or they just want to change it for aesthetic reasons. So, and we can even talk about the default way of playing, like the Western G4 that we see in the notation is actually played around D4. Not exactly 293-ish hertz, but it's somewhere around there. So, and it's mostly the aesthetic reasons. And the way we approach to this is when we after we compute the prominent melody, we actually compute this fine-grained kernel-based pitch class distribution, and we pick the peaks of the pitch classes to understand what can be the tonic candidate. And for each of these candidates, we basically try to do fragment linking. And like the basic idea is if the pitch heights are the same, then it should give us very confident links. If not, the confidences of the links will be just in the floor. So the highest one basically give us the tonic. And the second one, which we did, was the section linking. In this, basically the fragments are musically relevant structural elements. And these sequences are given in the score. So in the performance, people just do insertions, omissions, and they play. And how we apply to this is we first independently do fragment linking for each section, and then we get this graph, which basically is a very simple graph. It just shows if the start of a section is close to the ending of another section. And then we can search through these and find the most plausible sequence that they must have played. And then what we do is we actually fill out any, like, let's say, if the boundaries of some sections do not hold, we kind of guess them and fill those. So in the next step, what I would like to do is, the first is version detection. It's basically doing the tonic identification task to start by not assuming the score is linked to an audio, but I will just search the score through all of the audios, and I do section linking afterwards, so I could get the regions where everything is kind of played. Then I would like to go a little bit deeper into the beat level, not to note level, because of the conceptual problems I mentioned. And I would like to do audio score alignment to understand the intonation properties of this music. And it basically is the same fragment linking thing, except I need to do some kind of dynamic time warping, then half transform. Then I can actually sync other symbolic data, but we don't know what exactly these symbolic data are, like what are these characteristic phrases and motifs, which probably in the future I will collaborate with Sankalp and then the Comp Music Istanbul team. And another interesting thing, which I will not probably be able to in the PhD, is doing fragment linking for other musical cultures. And Gopal will actually explain what we want to do for the Varnam analysis, which is a forming Carnatic music. But when we were doing section linking, we actually tried the chroma features too, and we saw the HPCPs of Emilia actually work pretty well, so there's nothing that stops us from trying to link scores and audio for Eurogenetic musics. And these are the papers that we kind of sent. The Izmir one is accepted. JNMR we are still waiting, and these are references I did. So thank you for listening.